Okay, so we're just gonna continue with the second part of this lab, and we're gonna pick up where we left off and work with the buffering and clipping and intersect tools to explore the idea of layering, where different sources of pollutants intersect to see who might be at the highest risk in a community. So we're going to explore 3 different sources of pollutants in a community. And so we've got those sources of pollutants in our week 11 folder. And the first one we've already used, and that is our FRS facilities. So we can add that to the map. We had just been using all facilities in our first section of this lab, but we want to refine this a little bit. So in our facilities database list, we can open the attribute table, and we notice there is, we scroll all the way to the right. Let's actually move this up here. There's an interest type and a program type. And so there's a lot of information here, but all we're curious in is the information related to air, right? So we just want to find air pollutants, right? Because we're interested in potential air pollutants. So what we can do is we can use our selection query to visualize where these air pollutants are, and then a definition query to only display those air pollutants. So in my select by attributes window, I can open that up, and I can use a selection query in my PGM underscore SYS underscore AC field in my interest type field. And what I can do is I can double click this, and I can say PGM sys AC like, and so I don't know how many different types include air, but I don't have to know that because I can use a like statement, and I can use the wildcard to look for any record that includes the word air, right? So if I use like air, but I can't just use air, I have to use a wildcard, and I have to surround that in a single quote to say it's text. So you remember back from our selection by attributes lecture, where text has to be surrounded by single quotes, and then I use my wildcard to say basically anything can come before the word air. So it can be RICRA air, 123 air, it doesn't matter, it can be anything, but I can type the word air, and then I can type another wildcard, so anything can come after it, and then I can close that. So now it's going to look for any record with the word air. I can hit verify. I can say, okay, it was successfully verified, meaning the syntax was valid, and I can hit apply. And so now notice there are 4,734 that were selected. We see air, airs/AFS, and so then if we hit the view selected attributes button, which was this button right here, we can see really it's just 2 major program types. However, there's also this interest type, which could have air, and so just from experience, I know that there could be an air interest type that's not part of an air program system type. So I could use a combination statement. So I could say the program system like air, or, and I'll just go to a new line to make it easier to read, the interest type, and I'll just copy it and paste this one because it's easier, like air. So I could say if air's in this column, select it, or if it's in this one, select it. Verify, Okay, it was successfully verified. Perfect. I'll click apply. And so notice we get a record like this. So EIS, so air is not in this one, right? But it's in this one. Air emissions classifications unknown, because I said or air is in this one or it's in this one. If I said air is in this one and this one, this wouldn't be selected because air would have to be in both. So see how this, same thing here, we would miss out on all of these because this EIS program system acronym would be missing because we would be missing this air minor type. Right, so now that lets us visualize. So actually, before we close all this, let's just copy this whole statement. Cool. So we can see now where our air pollutants are. So they're pretty evenly distributed around the area. So we could unselect that. And so now we can double click on our FRS facilities. So we're still showing all of them on the map. And all we did was select by those attributes. What we want to do now is use that definition query to only draw those specific records on the map. And this definition query basically limits, uses the exact same methodology as the selection query to limit what's drawn on the map, so you don't see every point. And so we can use the query builder. So you notice it's the exact same thing as the selection query, and we can just paste that right in, right? So we can verify it. Great, successfully verified. We can click OK. You'll notice it shows up right here. And if you wanted, I could have just pasted it in right there too. Click OK, and notice how the amount of records is really greatly reduced because we're only showing the air pollutants. Cool. So now let's add the other two layers we're going to use, and that's in our week 11 folder. It's in our lab 11 folder, and it's in the data.geo database, and it's the major highways and the railways. So we'll hit OK. And so now we can see if we turn off the facilities, and let's turn off the railways, we see we've got our major highways throughout the area. And we turn those off, we have our major railways throughout the area. So not as many railways, but they're still there. So we've got these three layers, right? And now the goal is to see where the air pollutants, the major highways, and the major railways all are on top of each other, and where people are living near these locations who would be exposed to all three, and thus would be exposed to the highest levels of air pollution, either from these air pollutants or from particulate matter from the highways or the railways. And so we'll use our buffer and our intersect tools and our clipping tools from the first lab to help us do that. So the first thing we're going to want to do is we're going to want to refine our study area. So in this case, we've got these three layers. We want to refine them by Fulton and DeKalb County, which are these two counties right here. We've got Fulton County on the left, DeKalb County on the right. And that's simply just to make it a little bit easier to work with. And those are the two counties that I've downloaded the population data for, which we'll be using later. So we can use the clip tool for that, right? We want to clip our three layers, our three analysis layers to these counties, just so it makes the processing a little bit easier. Because if we're buffering all of these highways, right, that's extra processing time to buffer all of these roads out here. that we're not going to use. So it doesn't make sense to waste our time waiting for the computer to buffer all of these roads and all of these points and all of these facilities when we're not even going to use them in our analysis. So we might as well just remove them from the start because we don't need them, right? So there's two ways we could go about this, right? We could, because we need to set our kind of cookie cutter for this clip, we could use a definition query and remove all of the other counties besides Fulton and DeKalb, so we're left with just these two counties. Or we could simply highlight these two counties like we've done now. And when we input this Metro Atlanta set of counties into our clip tool as the cookie cutter, it's only going to use our highlighted selection as the cookie cutter. So it's a nice shortcut to be able to select a few records that you want to use as your cookie cutter in your clip tool to be able to run the clip tool. So let's go ahead and do that. So we're going to go ahead and clip these three layers. So we'll go to the toolbox, we'll open up our clip tool, and so we'll just start with our FRS facilities as our input layer, our input features. Remember, that's the bottom layer, the raw cookie dough that we're going to clip. Our clip features are the Metro Atlanta counties, but remember that they're only the selected counties because we're using that shortcut to only use these two counties because that's all we care about right now. And then we can just ignore that security warning. And then we'll select our output feature class. In this case, I'll keep it in my output folder. We've got all these outputs from our first lab. And I'll call it FRS Fulton DeKalb. That's not how we spell DeKalb. DeKalb. Well, we'll just call it FRS. Air FD. That's good. And we'll hit save. We'll hit OK. And now it's going to run the clip. Perfect. So now we've got just those FRS Air facilities in Fulton and DeKalb County. Pretty cool. So now let's just do the same thing with our major highways and our railways. So we could either go back to the clip tool, right, and enter everything again, or we could go back to the results window and the tool we just ran and just change our input to the major highways, right? We can leave the clip features the same because they are the same, and then we can just simply change our output feature class name to major highways, Fulton DeKalb. Click OK. Great. Done. So we can turn off. So now we have major highways in Fulton DeKalb County. Awesome. And then let's do the railways. And this time I'll just go back to the clip tool just to show you the difference. So we can drag our railways in, right? We could drag those in, or we could use our drop down to select them. The clip features, same thing. We can use our drop down. It's important to note though, right? We've got these two layers, or these two Fulton and DeKalb County, these two records, these two counties selected in the map. That's only going to work, and when we have them selected, we pull them into the clip features, it uses these two selected records. That only works if you use the layer from the map, right? We have Metro Atlanta here, we have Metro Atlanta here, right? We can pick it from the layer list in the map, right? If I go here and find Metro Atlanta shapefile, it's not going to work because it's pointing to the actual physical shapefile, not the layer from the map. So it's really best practice to add your layer to the map first, and then add it to the tool. So let's set the output. We'll call it railways. Save. Okay. Excellent. So now we have our railways, or our major railways in Fulton and DeKalb County. Great. So we can turn all those on. We can actually, let's remove our ones we don't need. Nope, we don't need that. So we don't need this one because that's for the entire study area. We don't need this one or this one. So let's get rid of those. So we've got just these for our study area. Great. So that's what we're working with. So now what do we need to do, right? Well, we need to buffer, right? We need to buffer our air pollution sites, we need to buffer our railway sites, and we need to buffer our highways, right? Because we're talking about air pollution, right? It's not something that's only affecting, this one specific site, this one specific point, right? It's in the air, so we need to buffer it by a specific distance because people around that location, people around the road, people around the rail are all affected. And this is where, if you're doing research, you'd want to do your research and really understand the distances for the specific air pollutants that you're buffering for or that you're concerned with. So if you're concerned with PM 2.5, so fine particulate matter, that's not going to travel as far as something, like volatile organic compounds, like VOCs. So you really need to know and understand what you're researching and what you're looking for. In this case, to keep it easy, we're going to do a couple things. We're going to buffer our highways and our railways at a quarter mile because fine or like PM 2.5 or not PM 2.5, like heavier particulate matter that comes off vehicles or diesel exhaust or car exhaust doesn't travel as far as fine particulate matter that might come out of an air polluting facility like these FRS sites. So in our buffer tool, we can open this up. So there's two ways we could do this, right? So we could, and we're not going to get into the model builder yet where we can string together tools, we can get into advanced things. So we can run our buffer tool twice. We can go buffer, run it for our railways, we can run it for our highways, and then that's great. So yeah, why don't we do that to start, and then we'll go the other way. So we can go buffer, we can go major highways, and so we'll set the output major highways buffer, and we'll go a quarter mile. So nope, not millimeters, miles. And we will dissolve all of these buffers. Okay, we'll run these. Great. So now there's our quarter mile buffer around our roads. And so let's do the same thing with our rail. So I'm just going to go back to my results and I'm going to open up my previously run tool and I'm going to change the input from roads to rails, and I'm going to change the output to railways Fulton to cab, buffer 1/4 mile, leave the linear unit at 1/4 mile, dissolve type all, and click OK. Perfect. Ran. Now we see our roadway buffers in purple, our railway buffers in green, and now for the air pollution sites, let's buffer those at a 1/2 mile. Because that those pollutants, because they're finer, right, can travel a little bit further than our heavier pollutants coming off our vehicles and our roadways. So we'll add in our input features, which are our air pollutants. We'll set our output features to FRS air, Fulton to cab, 1/2 mile. Oops, let's call it. And really, it really, I know I'm being kind of picky about naming some of these feature classes, but it really pays off in the long run to be diligent about naming them. So, you know, I could just leave them, you know, buffer 1, buffer 2, buffer 3, but if I'm coming back to this project in a day or two or a week or two, and I'm looking at all this data, I have no idea what this means, right? So it really pays off now. I can pick this up at a later date and time. I can look at my data, and now I know what these layers mean. So don't be tempted to just accept the default name. I know it's really easy, but it really pays off to take the extra 20 seconds to name your outputs more descriptively. So again, we'll dissolve all of them because in theory, right, the more pollutants you have overlapping, the more you're exposed to, but it really complicates our level of analysis right now. So in this case, all we're doing is we want to say yes or no, do people live where there's the highest level pollutants? You know, where there's all three, yes or no. We're not determining, you know, do they live where there's 20 air polluting sources or where there's 1. So we'll click OK. Oops, so I forgot my distance field. So we'll go 0.5 and we'll change that to miles. And then we'll click OK. It's buffering. Great. So now it ran. So now we've got all of them. So we can let's turn off our actual points so we can see we've got our buffers for our air, right, which are the tan. We've got our railway buffers, which are the green. Drag those up there. And we've got our roadway buffers, which are the purple, right? So now you can begin to see where they intersect and overlap, and we can begin to see there's a lot of places in the county, or in the 2 counties, where people probably live within all 3. Okay, so now we've got all 3. Next thing we need to do is we need to intersect them, right? We need to see where exactly all 3 intersect. So we can use our intersect tool. So we can open that up, and we can either select all 3 one at a time, or we can just select all 3. We can click the top one. You can hold the Shift key on your keyboard and click the bottom one. So we've got our railways buffer, our air buffer, and our highways buffer, and just drag them all into the input tool, right? And we can ignore the warning. Now we can select our output, so we can say air, highway, rail, buffer intersect Fulton DeKalb. Save. We'll join all the attributes. Leave the output type as the input type, so it will be polygons because they're all polygons. And we'll hit OK. And now we'll see where all three intersect. Cool, it ran already. So let's see, it's hard to tell. Let's change this color. By right click, again, I can change the color, so let's change it to red. Interesting. So, not as many as I would have thought. I would have thought there would be more, areas like here, but I guess it's hard to tell where all three intersect. Very interesting. So, basically, these areas of red are areas where all three buffers intersect. So where there are FRS, air pollutant buffers, where there are roadway buffers, and where there are railway buffers. So these areas in red are the areas that we're really interested in. These are the areas, and we turn these off. These are the areas that we want to get the population of, right? So we want to now add in some demographic data and see how many people live in these areas, because that's the ultimate goal, right? We want to know how many people in Fulton and DeKalb County live in these really highly air pollutant areas. And so we have population data in the Lab 11 folder. So in that same geodatabase, our data.gdb in Lab 11 folder, we have our Fulton DeKalb blocks. We can add that into the map. And this is block level data. We can zoom in here. So block level data so this is from the 2010 census. And so you remember from our population data lecture, block level data is the lowest level census geography. So this is the smallest level that population data is collected at. And so this is the most fine geographic aggregation of data. So this is fantastic data for doing this sort of analysis. And there's a couple different ways that we can do this sort of population analysis, but they vary in levels of complexity. So I'm only going to describe one right now, and that's just using the clip tool, right? So the easiest way to do it is to basically clip our demographics, or clip our Fulton DeKalb block data using basically our intersect or highly pollutant location data. So we can go into our toolbox and open up our clip tool. The other ways, include calculating some sort of area proportion. So if let's change this fill color to hollow and change the outline to like a red. So if I come in, let's take a good example here. So if I come in here, so area proportion is a good method, because let's take a look at this block right here. So let's look at this block. Right, we've got this block and this block right here. So this block is 100% contained by this polygon. That means 100% of the people living in this block are within this buffer, right? They're within this polygon. They are within this polluted area. There's no question about that. This block, on the other hand, that's not the case, right? So it looks, based on my eyeballing it, it looks like maybe we'll say 60%, 50, well, we'll say 55% of the block is covered by this polygon. And so what the area proportion method does of population, so the area proportion population estimate method does, is it basically just estimates the area of your population polygon, or your input polygon, that's covered by your study polygon here, and multiplies that percentage by your population. So, example, if there are 100 people that live in this census block here, 55% of my census block, right, so this part here equates to 55% of the total area of the census block, is covered by my pollutant or my study polygon. That means it's going to estimate 55 of the 100 people living in the census block are covered by that polygon, right? So that's the area proportion method of population estimation, right? The method we're going to use is easier, right? The method we're going to use is basically saying, okay, this polygon, our study polygon, touches this block. So the entire population of this block, we're saying, is covered by this polygon, because we don't know if all of that population lives right here or if they live right here. We don't know, so we're going to make the judgment call that they all live within this study area. The third way is to create a centroid. So basically, create a point at the center of each one of these block polygons. So a point here, a point here, a point here, a point here, a point here. And if that centroid falls within our study area, right, then it gets attributed to our polygon and we add up the population. So for this block here, the same block we've been working with here, its centroid would probably fall within our study polygon here, and the population would get attributed to this polygon. So we'd add that population up. However, this block probably wouldn't. So the method we're going to use would attribute 100% of this block's population to our study polygon. So it's probably going to overestimate the amount of population that is attributed or that lives within our polluted area. The centroid, the block, or the centroid method, where it creates a point in the middle of the block, and then if that point falls within the study area, it apportions the full population, wouldn't apportion any population because our centroid does not fall within our study area. So that's going to apportion 0 population, which would actually probably underestimate, whereas the area proportion method would take approximately, 20% of the population living in this block and apportion it to this polygon, which would actually probably be the most appropriate, but it's also the most complex, which is why we're not going to do it. At this point in time, that's probably more of an intermediate GIS class. I just wanted to explain it for you. So we'll zoom back out. We'll open up our clip tool again. Our input features, ignore that. Will be our blocks. Our clip features will be our buffer intersect, which are our polluted areas. And then our output features will be, we'll call it population in, we'll call it try buffer because there's 3 things in it, so we'll just shorten that to try. So population in try buffer, fold into cab. Click OK. Great. Cool. So done. So now if we turn off that, so we can see we have our population in this buffer. And so what we can do, if we open up our attribute table of our clipped layer, we can see there are 3,000 blocks, and if we scroll over to the total population, we can simply just right-click on the field header and go to Statistics, look at the sum, and tell there are 182,000 people living within our most heavily or air polluted areas in both counties, based on the air polluters from the FRS database, the railways, and the highways. Pretty cool, right? I think it's pretty cool. We've got other population data, so we can look at our age less than 6, right? So there's 16,000 young children who are especially sensitive to that, right, to air pollution. There are 14,000 elderly who are also especially sensitive. So I think that's really informative. That's pretty cool. And this is information that you can only get using GIS, right? So there's no other way to get at this information, right? This is really the power of GIS. So we can take it one step further, right? We can use our summary statistics tool, because what if we want to know the difference between Fulton and DeKalb County, right? So that was just both Fulton and DeKalb County. Well, if we open our summary statistics tool, right, and we want to look at our input table, which is our population in our tri buffer, and okay, we'll change our output table to tri buffer stats, and we'll call it .csv, or we'll just do a .dbf. In our statistics field, this is where we can choose our fields. So we'll just do total population. We'll do age less than 6, and we'll do age over 65, and now we can choose our statistics type. So I just want to do sum, because I want to know the total number of people, and then I want to stratify it by county. So this is where we have to figure out the state county. There should be a county state ID. Let's try and figure that out. So I'll show you what happens. So let's just do this. Let's just run it. We'll call it all. Let's run it without the state county ID, and I'll show you the difference. So we open. So now, right, we get the same numbers that I showed you from the field headers, right, from using the right-click statistics, right, 182,000, 16,000, and 14,000. But because it just does it for everything. But we want to stratify that by county. So we can zoom in here. And so our block groups should be split by county. So we have state ID 13, county ID 89, which should be DeKalb County, and Fulton County is 121. So I'm looking at the county FIPS code here. So Fulton County is 121. DeKalb County is 89. So if we look in here, block county ID 89, and if I look here, county ID 89. Oh, interesting. County ID 121. So our county line might not be as simple as this straight line. So we need to basically see if there's a field in our block that is just 13 and just the state and the county ID field concatenated together. So we see the GeoID, it's 13121, but it has all this extra. There's not, so that's tricky. So let's do that. This will be a short primer, I guess, into field calculations. This is gonna be a whole nother class in field calculations. So don't worry about it too much right now. So we can click on our table options. We can add a field. We want to add, we'll call it ST County. We'll make it a text field. We'll call it length 5 because it only is going to be 5 digits. Click OK. We'll scroll over to the right. We'll go right click, field calculator. We'll choose the Python parser, and all we're going to do is we're going to go state ID plus county ID, because we're simply just combining these two fields, because we have our state ID 13 and our county ID, which is either 089 or 121. Click OK, and then it ran. And so now if we go back to here and I click on this one, I can see all the way at the bottom state county 13089, state county 13121. Perfect. So let's go back to my summary statistics, and we'll change the name to state county, we'll add county after it, because now we want to stratify it by county, which is our case field, right? So this is why we calculated the county, because we want to say what are these fields, right? What are the sums of the total population, the age less than 6 and the age greater than or equal to 65 for Fulton County and for DeKalb County, which is why we needed this specific state in county, or the specific county identifier. And really, now that I think back on it, I was dumb, and we could have just used the county ID. That was stupid of me. We could have just used the county ID. We didn't have to create the state county ID, because we're just dealing with two counties, right? 89 and 121. If you were dealing with multiple states, then you couldn't just use the county ID, because multiple states have counties with the same county ID, 121, 89. But because we just have the two counties in Georgia, there's no reason we can't just use this 3-digit county ID. Either way, I got you saw a quick preview of the field calculator. So we'll click OK. That runs, cool. It shows up in our table of contents. We click open. Cool. So now we can see DeKalb County is 89. There are 6,000 kids less than 6, and then there are 10,000 kids less than 6 living in the highly polluted areas in Fulton County. Now though, so obviously there are more people in Fulton County, so there's going to be more kids. We can do another quick field calculation though to do the percentage. So we could either break out our calculator in our windows, and we could just do 6121 divided by 63240. So 9.67%. Basically, if I divide, get the percentage of kids under 6 in DeKalb County living in the highly polluted areas, so it's 9.6%, and compare that with the percentage of kids in Fulton County, so 10, 0, 5, 1 divided by 11, 8, 9, 0, 4. So there's actually a higher percentage of kids in DeKalb County living in close proximity to an air pollutant source than Fulton County. And so we did that with our calculator, but we can do it here in the field calculator as well. So we can add field. We can percent. Let's go age LE 6%. And double means we allow decimal points, which we want. And again, this is more I just want to show you. We go back to the field calculator, and we'll do parentheses because we want to force our order of operations, just like any normal math problem. So we'll go age less than 6 divided by total population times 100. And we probably don't need the parentheses, but I like it just to keep things straight. And that will get us our percent. So we have 9.67% and 8.5%, right? So we could do this on a statewide level, right? And get the percentage of kids in each county living near a air pollution source. So that really, in my mind, is one of the greatest powers of GIS, right? There's no other way you could do that. There's no other way you could stratify that data or come up with this answer to the question, what's the percentage of kids living near an air pollution source on a county by county basis without GIS. And we did that relatively quickly. I think it's really cool. So for the assignment, we'll be doing similar work, just different data. One tool you might use, which we haven't worked with, is the erase tool. So basically, it's the opposite of the clip tool, right? We've got our input features, which is our sheet of raw cookie dough, the erase features, which is essentially your cookie cutter. But instead of only leaving you with what you cookie cutted, it just removes that. It deletes it or erases it. So exact same thing, just the opposite. So that's it for this lab.